All right, I want to answer a frequently asked question about this quadratic project. Some of you guys have chosen this for your quarter 3 final, and this is the template I gave. This is the part that you start with, and of course it works if everything's perfect, if it has an integer answer, but it doesn't work if they put a bad input or if it tries to do something involving a negative square root. It can't do that. So in a real quadratic function, you can do that by introducing what they call complex numbers with I, or sometimes it's called j, but either way it represents the square root of -1. So how can we do that? Well, it's not that hard to do a simple version. It is hard if you want to make it like make the radicals look good and reduce the fractions and make everything super pretty. But if you just want to throw some decimals in there, turns out we can do that. So this is the version that works without complex roots. So I'm going to have like, if it needs it, we do something else. If I'm going to make up a Boolean that we'll use later. If has complex roots, we'll do something else. We'll do this stuff. And how do we define that Boolean? Well, it's going to be based on this guy. This part of the equation that's inside the square root is called the discriminant. So I'm going to give it a name, even though it's not a short name. And then I'm going to put that in these spots, which you don't need to do, but it's nice. Theoretically, it saves the computer a little bit of calculation, and it makes it, in my opinion, easier to read. But it would have worked without this. And I'm going to make another variable that you don't need, but again, I think it's nice, is the one I introduced a minute ago. It's going to say has complex roots, which is discriminant less than 0. So if it's less than 0, we couldn't do this. We couldn't take the square root of it. So we need to have something else happen instead. Now, this is going to be almost the same. We're still going to do -b plus something over 2a, but we have to change this guy a little bit. And what we're going to do is take the square root of absolute value and then throw on an I. So like if it was -16, we would take the square root of regular 16 and then throw on an I, which would be extracting the square root of -1 from that radical. And speaking of radical, I'm going to use that as the name for this. Some people have a different style and they don't want to name everything and they want to keep it more algebra looking, symbolic, A and B and X and Y. I like to give everything a name and then be able to use that later. But there are many, many ways that would work. So don't worry about that. For this, I'm going to say radical equals square root of absolute value of discriminant. And we could just say negative discriminant, because theoretically, if we get here, it would be negative, and that would switch it to positive, but it's fine. And then I'm going to say we're going to build a little string using the parts we have. Okay, we're going to say something like, I don't know, let's try it and see what happens. Root 1, I'm going to make what they call an F string, which is where you have the ability to put stuff in quotes, but also throw in variables that will be filled in based on their value. So I'm going to say our first term is negative b, and then plus radical I, and then we could do divided by 2a, but for this it's already going to be kind of an ugly decimal thing, since we're taking the square root, even if it doesn't result in an integer, like square root of 5 is going to be 2 point whatever, whatever, whatever. So we might as well just resolve those quote-unquote division problem and just do like b over 2a and then radical over 2a, you know what I mean? So the final answer would be like 5 plus something I. And so I'm going to do divided by 2a, divided by 2a. And since this is a thing I'm going to use a million times, you know, twice here and twice in the other one, a couple times here. As before, I'm going to give it a name. You absolutely do not have to, but I'm going to do it. One reason is it makes it readable. Another reason is it saves the computer from having to do that multiplication every time, although it can. Another reason is I was a tiny bit worried about the order of operations. Like if I say negative b over 2a, does it correctly do that? Does it multiply these before dividing, or do I have to do this? I don't know. But if I say denominator, I don't have to worry about that. And I'm going to do the same thing here. Even though, yeah, it's longer, but that's okay. And that is gonna do the job. I mean, we got to test it, but let's do the root 2 as well, which is the same thing with the minus. So this is going to end up saying, okay, we took the square root without the negative part, and then we're putting the negative part back in with this I. So let's run it. And first, let's try something without complex roots, just to make sure that we didn't mess it up, you know, that we didn't ruin what we had. And that's still good. So now let's try one with, and that's how it ends up looking. Okay. Negative decimal plus a big ugly decimal, I. Now, I hate that. I would not want to read that, especially the I is easy to lose at the end of a long decimal. And I would rather say like square root of 2 or square root of 3 or something. But this is a great start, and it does solve the problem, which is it used to not be able to do that, and now it is able to do that. Pretty big leap, right? With only a couple lines, and it's really twice as many as we need. I just like to give things names. So if you didn't, you could do it in a fewer lines. Now, obviously, there are other ways to achieve that, but this is something I like, and I think it makes a bit of sense to my brain. Plus, it allows us to expand later if we needed to do stuff like, what if I wanted to use fractions instead of decimals? What if I wanted to use radicals instead of their solved ugly decimal form? I could have a better shot at doing that after having given things names, or at least it would be easier for me after having given them names. So think about it, and if you want to do something like this, it would be not too hard to implement.